In this video, we're going to learn about Bronsted-Lowry acids and bases. So we learned previously that the Arrhenius definition of acidity and basicity is all about whether something can dissociate to form H plus or ionize to form OH minus. The Bronsted-Lowry definition is a little bit broader than the Arrhenius definition. And actually, Bronsted-Lowry that definition is all about H plus. Is something capable of donating H plus, and is something capable of receiving H plus? Um, and basically, all Arrhenius acids or bases will fall into the category of Bronsted-Lowry acids and bases. But an example of a Bronsted-Lowry acid that is not really an Arrhenius acid would be H2O. Arrhenius acids, it's all about increasing the concentration of H plus relative to water. Water isn't going to really increase the concentration of H plus relative to itself. Um, so water really isn't isn't really an Arrhenius acid. It is a Bronsted-Lowry acid in the sense that it is capable of behaving in a way where it does donate an H plus. More on that in a minute. Um, Bronsted-Lowry bases that are not Arrhenius bases, well, a good example is NH3. NH3 is not hydroxide. It is not OH minus. But like hydroxide, it is perfectly capable of reacting with an acid and picking up an H plus, accepting an H plus. So let's see how Bronsted-Lowry acids and bases behave. In this case, HCl is going to be, well, an acid, and it's an Arrhenius acid, just as it's a Bronsted-Lowry acid. It is going to donate an H plus to the H2O. And what we see is that the H plus comes over here, and we end up forming H3O plus and Cl minus. So this would definitely be a Bronsted-Lowry acid because it is donating an H plus, and this is going to be a Bronsted-Lowry base because it is receiving an H plus. Now, we've seen water acting as a base in this case, but also water can act as an acid. And look, in this case, we have NH2 minus, which is an extremely strong base, reacting with water, which is somewhat basic, as we can see, but it also is capable of acting as an acid. What's happening here is that the H plus is going over, um, and we end up getting NH3 and OH minus. So our acid is water in this case, and our base is NH2 minus. And in truth, acidity and basicity is all relative. I have seen cases where nitric acid has behaved unmistakably like a base, even though we call it an acid. It's just that if it's in a condition where it's with something extremely more acidic, well, then even a strong acid will potentially act as a base. And even a base, even a strong base, is capable of as acting as an acid if there's an even stronger base for it to react with. It's all relative. I do want to throw in here the concept of monoprotic and polyprotic acids because they definitely come up. Polyprotic, poly means many, so we could have diprotic or triprotic, uh, di meaning two, tri meaning three. Um, the definition of monoprotic versus diprotic versus triprotic, it just depends on how many H plus an acid can donate. HCl is definitely monoprotic. Um, H2SO4 is definitely diprotic. The first H plus, very easy to remove. The second one is harder, but it is something that can be removed. And in H3PO4, this is triprotic. The first H plus comes off quite easily. The second one is harder, and the third one is harder still. And what we can actually see is a case of the equilibrium between H3PO4 and two other forms. We start with H3PO4. It can lose an H plus to become H2PO4 minus. It can lose another H plus to become HPO4 with a -2 charge, and it could become just the phosphate anion if it loses all three protons. And it really depends whether it goes a little of the way or all the way. Depends on the conditions that it's in. If it's in enough base to rip off three protons, then it will be deprotonated all the way to phosphate. And if it's only in the presence of enough base to get rid of one of the protons, well, then it will be H2PO4 negative. And so that's how the concept of monoprotic versus polyprotic acids comes into play in this unit. Anyway, I hope this video has been helpful. Feel free to leave any questions or comments in the comment section below. Thanks for watching.